Next problem. প্রথমে আমরা এটাকে প্রথম যে এই পাশের টার্মটা আমরা সেটাকে ফ্যাক্টরাইজ করে দেব। তো সুতরাং সিএফটা সিম্পলি যেটা হবে now for the PI well, as far as I am observing, no singular cases being arised. A or f of AB is never is equal to 0. So if so, we can directly put all these values. So 1 cube 7 into 1 into 4 16 2 into 3 cube, sorry, triple integration of sine v dv 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 when your v is equal to x plus 2y. Calculate this and you will be finding this is equal to 1 over 75 cos of x plus 2y. Next problem. So this is the factorization and one multiplicity is there. So your CF is equal to arbitrary function of y plus x, x arbitrary function of y plus x plus y plus 2x. And PI, for PI point is there will not be any f of AB is equal to 0 case. So directly putting the values we can obtain 1 cube minus 3 into minus 2 square 2 into minus 2 cube dv. So we obtain minus 1 over minus 27. Your v is x minus 2y, so it will be x minus 2y to the power 7 over 2, 3 by 2, 5 by 2, 7 by 2. So simplify that and you will be finding 8 over 2835 x minus 2y to the power 7 over 2. Next problem, dq minus 3d d dashed plus 2 d square 2d dashed square operating on z is equal to cos x plus 2y. So factorize that, x minus d minus 2d dashed operating on z, this is equal to, so CF is phi 1 y plus x plus phi 2 y plus 2x. Okay, now moving for pi, no 1 over 0 case, so 1 square 3 1 2 2 2 square double integration of cos v dv when your v is equal to x plus 2y. So this is cos v, that is 1 over 3 cos of x plus 2y. Day 9, last part will be we will be constructing a new formula. Suppose your f d dashed is inversely operating on a function f of xy, which is in the form x to the power m y to the power n. So what we will do, we will take some d or d dashed common and we will expand that part, but we will remember if m is greater than n, then we will expand the thing for a power of d dashed by d, and if m is less than n, we will expand the 1 over f d dashed thing in a power of d over d dashed. So better if we go for some problems. So the first problem is d square minus a square d dashed square operating on z is equal to x. And so what we will do, the CF part is simple, you can write it as 1 d dashed and d minus d dashed. So CF is phi 1 y minus x plus phi 2 y plus x. Okay, pi part where the new formula will be applied. So see, this is, as we see that your x's power is greater than y's power, right? So we are moving as d square 1 minus a square d dashed square over d square. This will be applied with x. So we can write it as 1 over d square 1 minus a square d dashed square d square to the power minus 1 for x. So the expansion is like 1 over a square d dashed square d square etc. for x, and the only remaining term is d square x and double integration, so x square x cube and 2 3, that is 6. This is the pi. And next problem, d square plus 3d d dashed plus 2d dashed square operating on z is equal to x plus y. So directly see, you can break it like d plus d dashed into d plus 2d dashed, and your complementary function will be phi 1 of y minus x plus phi 2 of y minus 2x. I'm not going that for that part. What will be the py? Now pi is directly I'm taking common d dashed square, and you have 1 plus d over 2d dashed square plus 3 over 2 d dashed x plus y. So 1 over 2d dashed square, and breaking the other part, 1 minus 3 by 2 d dashed, etc., operating on x plus y. So if you take the first part and then integrate, so it's like x y square over 4 minus y cube over 24. But the same thing, whenever you are doing taking a d common, then what happens? You can see that if you take d common, then the same result is coming as y x square by 2 minus x cube by 3. And so preferably what we should do, I mean, see, two different results cannot be allowed. So actually what you must do for that part, take d common, so d dashed over d, that part should be expanded, and for this part take a d common, so a d dashed common, that's why d over d dashed, that part should be extended, and your result will be a correct one. So using this formula as well, we can go through different problems. So I'm not just elongating this class. You can just find out some problems from different books and solving them, and that can help the learning methodology.